and the audio. Yes, you can hear me all right. You can see me okay. All right, all of you. Can you confirm? I want at least one or two or three of you to confirm.
Yes,
Yes,
sir.
no, not
Yes, sir.
perfect. Great. So I think, we are here. You know these chapter. You have already done this chapter. You're masters. I know. Yet, some of these chapters are landmark chapters. When I say landmark chapters, they're huge chapters. It's not only about class 9 motion, folks. It's not only about class 9 motion. It's also about the force and laws of motion that you're going to do next, gravitation that you're going to do next, quite something about workforce and energy as well that you're going to do next. So every chapter in class 9 physics has something or the other to do with motion. That's one. Even more important, I wouldn't say more important, but equally important, is that the entire class 11 physics is motion. There is one book, which is there are two books in class 12, class 11, two physics books that you'll have, part 1 and part 2. One part is all about motion. That book itself is motion. So you can by now, you could have by now made out how important the basics of this chapter is. We are not looking at memorizing and writing. It's like, it's not about committing to memory and vomiting in the examination. Many of us do that. So it's time to stop doing that. It's about understanding a touch more. You might be able to do the numericals. You might be able to write the definitions, but do we really understand the concept? If yes, if yes, then the good marks that you're scoring, 90-95%, will extend into the future, 10th, 11th, 12th as well. But if we are only memorizing now, and not really understanding, we may still get 95, yes, A plus, but it will start showing. The gaps will start showing very soon. So let us be careful. Let us really get things right. So the first thing that we have is obviously the definition of motion. And this is a very small definition, but it means a world of things, folks. Let us get everything right. It is the change of position of a body with respect to time or any other body. This is something that you have read. There could be other definitions, but essentially this is what it means. So my question to you is, am I at motion right? Am I moving right now? Or am I at rest? What do you think?
Rest.
I am at rest. Anybody else has any other answer?
Sir, with respect to Earth, you are in rest, but if you see from the moon, you are in motion.
Perfect. Very good. That's what I wanted to hear. So this definition, read this again. It's a change of a position with respect to time or any other body. With respect to the moon, am I not moving right now? Yes, I am, because I am on Earth and the Earth is moving with respect to the moon or the sun or Mars or Jupiter or Saturn or Neptune or Jupiter or Plato or any of these. So this is very relative, folks. I am at rest with respect to this board. I am at rest with respect to you all, because you are not moving. I am also not moving. We are not moving with respect to each other. That's important. We are not moving with respect to each other, but we may be moving with respect to some other object, and therefore we are at rest with respect to some bodies, and we are at motion with respect to some other. Is this absolutely clear, folks? Absolutely clear. 100%.
Yes, sir.
Yes. Perfect. So this is one big thing that we must be very clear about. This is where our basics start getting better or worse. If we're not following the small little things, folks, we start on the gap, which becomes impossible to bridge after 6 months, 8 months, or 2 years. So it's important that we don't let these gaps fill in. Let's be bang on target right from minute one. So I am at rest. You can write these notes. I'm not writing everything on the board. I want to quickly go through these things. So maybe I'll just write the summary of what we just talked. So I am at rest right now. Write this down. I am at rest right now with respect to you, but at motion with respect to sun, moon, etc. Meaning the summary is motion is relative. With respect to one body, you are at rest, and with respect to another body, you might be moving. I'm not taking any more examples, folks. We don't want to discuss theory for 1 hour, but this is a very important thing. Now, we'll come to some of these definitions. Distance. What is distance, folks? What is
The total
distance?
path from the initial to final position.
The
Perfect. So,
distance traveled by a body.
डिस्टेंस इज डिस्टेंस ट्रेवल बाय बॉडी ये कौन सा डेफिनेशन हो गया डिस्टेंस में ही डिस्टेंस आ रहा है हाउ कैन यू यूज द वर्ड डिस्टेंस in the definition I know that you know we all know these what really it is right we have known this for tens of years but are we really able to define so I hope you are good with this I'll need board space folks so I'm erasing this are you people good and make sure that you are noting these things down make sure that you are noting these things down because when you are revising you will get the right context if you are making proper notes now if you really understand these 5 definitions properly, folks, I guarantee you that you are 80% good with motion. That's my guarantee. Now let's look at some of these definitions. So it's the total or the actual path between 2 points. Or the length, you can just write the length of the total path. The length of. So I will take the example of your school, DPS Nacharam, beautiful school, DPS Nacharam. And here we have Habsiguda Crossroad. I hope you know where Habsiguda is. This is approximately 3 kilometers. If you go on the Mallapur Nacharam road, it is 3 kilometers. But you can also go via Maulali, yes, in which case it will be, let's say, 6 kilometers. You are getting it. So if you are going this way, the distance is 6 kilometers. If you are going this way, the distance is 3 kilometers. Yes, all of you. Is there any other way you can go from DPS Nacharam to Habsiguda? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, you can actually go to Bangalore first and then come to Habsiguda. That's also possible. So in that case, the distance will be 1300 kilometers. So whenever you have actually, that's important. Whenever you have actually traversed or followed this path, the actual path where you are walking or driving, that total path is the distance. So the distance between 2 points could be 3 kilometers, 6 kilometers. If you first go to Bangalore and then come back to Dabsiguda, it will be 1300 kilometers. If you go to New York and then come back, it might be a few thousand kilometers. All these are correct. All these are distances. But what is the shortest distance between these 2 points? It is the straight line joining these 2 points, which is 3 kilometers, let's say. This is called displacement. So this is called, so we discussed distance, which is the actual path, the length of the actual path. And from this, you can derive displacement. And displacement is what? The shortest distance between the initial and final position of a body. It's the shortest distance. I just told you that there can be hundreds, thousands, millions of distances from DPS Nacharam to Habsiguda. You go via Maulali, it's 6 kilometers. You go to Tarnaka first and come, it will be 10 kilometers. You go to New York and come, it will be 10,000 kilometers. But which amongst this is the shortest distance? The shortest distance is the one that you take straight from here to here. That distance is called displacement. So are we absolutely crystal clear about what is distance, what is displacement, and how the two may be different?
Yes, sir.
Yes?
Yes, sir.
Yes,
And
sir.
when I say the two may be different, get the word right, may be different. It may not be different. If actually I have traversed this path, then my distance and the displacement are the same. So is it fair to say that distance is greater or equal to displacement? but distance can never be less than displacement. It can be greater or equal to. Equal to when? When is this equal to? When we have taken the shortest path between two places. That's distance. So that's displacement as well. But if we go via New York or if we go via Bangalore, obviously distance is much more. So I hope you people are very good with respect to the definition of motion, distance, and displacement. Yes, class 9 folks, is that absolutely clear, all of you?
Yes, sir.
Yes, sir.
Wonderful. Jaldi se note karo. Note this down, whatever. We will now talk speed and velocity. You will just get this right, folks. Speed and velocity, we have a lot of misconceptions. We will get everything right if we are attentive. Just copy this very quickly. This part very quickly. Write the definition of distance, write the definition of displacement. I know that you know, but write what all I'm writing, because everything will set the context for the next thing. If you are missing out on something, you may miss out on what you have written going forward. So just make sure that you are writing these things down, even if you know. Very quickly copy this down.
Sir, someone is on their video mode. Can you tell them to turn it off?
Hey, please turn your video off, folks. It just gets the screen. Thank you. Is that all right now?
Yes, sir.
Okay, so please be on mute unless you are speaking, folks, and don't keep your video on. Just you can always unmute yourself and ask a question, right? Otherwise, there are at times background noises. All right, so I hope we are good with this as well. Now, bring all your attention, folks. Bring all your attention. Don't think about anything in the world. The Euro, the World Cup cricket, the Olympics coming up, all these will happen. For now, let's pay attention on the next thing. Now, let's say in the year 2020, just get this right, folks, you will understand speed and velocity. In the year 2020, your height, in the year 2020, let's say your height was 120 centimeters. In the year 2040, let's say you are now 160 centimeter tall. So what is your change in height?
40 centimeters.
40 centimeters. 40 centimeters, sir.
Get this right. Get this right. It's the final minus the initial. Is that clear? The difference can be 120 minus 160 or 160 minus 120, but the change in height is always the final. What you are now minus what you were 4 years ago. So it's the final minus initial height. So it comes to 40 centimeter. Wonderful. Now, if I ask you, what is the change in height, the total change in height, the total change in height divided by total time, then in this case, I get what? 40 divided by 4 years from 20, sorry, it's not 2040, it's 2024. So in 4 years, this is what you get. So this comes to what? 10 centimeters per year, right? Now, how do we read this, folks? We read this as 10 centimeter per year. 10 centimeter per year. Per means 1. But here, are we only talking about 1 year? No, we are talking about 4 years. Yet, we say per year. What does this mean, folks? What does this mean? This is very important. It is happening across 4 years, but when we are dividing the total change by the total years, what we get is 10 centimeter per year. So is this not the average change in height per year? Average change in height per year. You might have grown 8 centimeters in the first year, 12 centimeters in the second year, 13 centimeters in the third year, and 7 centimeters. So you would not have actually grown 10, 10, 10, 10, 10 across all years, but your average is 10 centimeters per year. Is that clear, all of you?
Yes, sir.
So I repeat, you might have grown more in 1 year, less in the other, more again and less in the other, but your average is 10 centimeters per year. Get this right. Understand this right. You will understand average speed from this. So if you have understood this completely, just get this right now. Here, we are going to Bangalore, okay? So from Hyderabad to Bangalore, the distance is 600 kilometers. Depends on where you are going, but we are going to a point which is exactly 6 kilometers from here. And the time that we take, let's say, is 10 hours. Absolutely clear. So we are now going to calculate the average speed. The average speed is equal to total distance by total time, total change in height by total time. That's what gave us the average change in height every year. Here we will get the average speed per hour. So in this case, is it not 600 divided by 60? Sorry, it's 10. 10. 600 divided by 10 hours. So how much do we get? What was our average speed? The average speed was 60 kilometer per hour, right? So this is the average speed. Average speed means what, folks? Now get this right. What is average speed? It is not the speed that we are driving it at all the time. It is the average, right? It is the average. We might have been driving at 100 kilometer per hour sometime, and because of some traffic, we might have slowed down at other times. At other times, we might have taken a breakfast break. At other time, we might have taken a juice break. But the overall average is 60 kilometer per hour. Is that clear? So this is our average speed. Clear, all of you?
Yes, sir.
Clear? Now,
Yes,
if
sir.
we just look at average speed and average velocity, we can make out here. Now, coming back to our earlier example, earlier example, let's say we were in DPS Nacharam, and we are going to Habsiguda. And from here to here, what is the total distance? The distance which is the shortest distance I'm talking about. This is 3 kilometers. Yes. But you decided to go to Gachibowli first and then come to Habsiguda. And then in the process, you actually took a total distance of, let's say, 60 kilometers.
Hello, sir.
Yes,
Are you able to hear me?
velocity. We usually use the terms interchangeably, right? We think that velocity and the speed are the same, but they are not. Let's see how. Now, I'll take this example again of TPS Nacharam to Habsiguda. Yes, all of you. And we decided that the distance between these 2 points, the shortest distance was 3 kilometers. Okay. Now, in this case, there is one person, let's say person A, who goes, no, this is A, the person A takes this shortest route, and there is one person B who goes to all places in the world, Gachibowli and everything, and then comes to Habsiguda. In the process, B has traveled a distance of 60 kilometers. Are you just able to appreciate the two scenarios, folks? Don't think too much. Just tell me if you are able to appreciate the two scenarios. A goes directly from here to here. He travels 3 kilometers, and B goes all the way to Gachibowli and God knows where not. And then he came to Habsiguda and he traveled 60 kilometers. Absolutely clear, folks. Absolutely clear.
Yes, sir.
Yes. All right.
Yes,
Now,
sir.
the time that he takes, the time that this guy takes is, let's say, 3 hours. And the time that this guy takes is, let's say, 1/5 of an hour. You know what? I'm writing in hours so that we are consistent with the units. 1 by 5 hours is how much? 12 minutes. There was heavy traffic, so that is only 12 minutes. Okay, it's 1 by 5 hours. So now can we look at their speeds? So in this case, what is his speed, folks? Speed is equal to total distance by total time, and that comes to 20 kilometer per hour. Yes, that comes to 20 kilometer per hour. And what is this guy's speed? This guy's speed is 3 divided by 1 by 5. So it is 15 kilometer per hour. So we are good with the speeds, right? We are good with the speeds. Now, what about his velocity? What is his velocity, folks? Velocity is equal to displacement.
Displacement by time.
So in this case, do you agree that the speed and velocity will be the same because distance and displacement? Speed is what? Speed is equal to distance by time. Calculate. So the summary here is, I'm just summarizing. Whoever has missed, you can. I will just summarize this now. Okay. I think this result that you see is all randomized here. So I'm just going to summarize everything. Just summarize everything. So between 2 points, A and B, let's say this is again DPS Nacharam and Hapsiguda. Somebody is taking 1 by 5 hour to complete this.
1 by 5 into 3
So in this
kilometers.
case, no, why 1 by 5 into 3 kilometer? Why? What are you trying to achieve? Just let's no 1 by 5 into 3 will not give us any quantity, folks. So in this case, what I'm saying is, what is the, just tell me what I'm asking, folks. What is the distance for this person? He's going directly from DPS Nacharam to Hapsiguda. So what is the distance for him?
3 kilometers.
3 kilometers. And what is the time that he is taking?
1 by 5.
1 by 5 hours. Therefore, his speed is given by distance
by time.
So
Equals
this
3
is
by
divided by 1 by 5. So it will become 3 into 5. It becomes 15 kilometer per hour. Absolutely clear, everyone. No doubt about this at all. And for him, the displacement is also the same. In this case, sorry, it is velocity. Velocity is also the same because displacement by time will also be the same. 3 divided by 1 by 5. So this becomes 15 kilometer per hour. So are you clear that when distance and hold on, just listen. This is the last important line, and you can then ask me questions. When distance and displacement are the same, speed and velocity are also the same. Is that clear? Is that making sense to all of you? When distance and displacement are equal, speed and velocity are also equal. How many of you have not got this statement right? Let me know. If you have any other questions, you can now ask me. Copy down what we have noted.
Sir, but in some cases they give velocity different and distance different.
Average speed we already talked about, right? From here to Bangalore, it is 600 kilometers and you took 10 hours. So the average speed is total distance by total time. Total distance by total time is average speed.
So 600 by 10, sir.
We'll come to. Yes.
600
this is
by 10
speed,
is,
no? Total distance by total time. This is a Go ahead. Say again.
Sir,
Yeah.
average speed I need.
And that's what I'm telling you. No, average speed is total distance divided by total time. That's average speed. Simple as the total distance. From here to Bangalore, it's 600 kilometers.
Sir, not that, sir. When a car is traveling 20 kilometers per hour in 1 minute, so how much how much distance can it travel in 3 hours?
Now we'll come to the numericals. Let's get the theory right. We'll come to numericals. We'll have all the kinds of numericals which we are coming up with shortly. Have you understood this? Don't let us not skip things which we are trying to understand to get confused with things that we are not clear about. Again, I repeat, let's not jump things. If we do not understand what is going on here, we will never get the remaining things clear. So let's take baby steps. Is this scenario clear to all of us? A person actually travels from DPS to Hapsiguda, taking the shortest path, which is 3 kilometers. So for him, the distance and displacement, they are both equal to 3 kilometers. When distance and displacement are the same, the speed and velocity are also the same. Why? Because speed is distance by time and velocity is distance by time. Is this clear to every one of us? Is this clear to every one of us?
Yes, sir.
All right. Now we will understand another scenario when somebody is actually taking a different path. This guy took the shortest route, right? This guy took the shortest route. His name was A. A took the shortest route. Now we are talking about B. B, what did he do? He did not go directly from DPS Nacharam to Hapsiguda. But we all know that the displacement between these two places is 3 kilometers, right? No matter which route you take, the shortest distance between these 2 points will always be 3 kilometers. Is that clear to all of us? He actually went to Gachibowli and then came back over here. So he traveled 60 kilometers. So for B, can somebody tell me what his distance was? And can somebody tell me what his displacement was?
Sir, displacement is 3 kilometers and distance is 60 kilometers.
Wonderful. So you've got it right. Distance is 60 kilometers. It's the actual path. Look at the definition. It's actual path. And this is the shortest distance. So this is 3 kilometers. Absolutely clear. And the time that he took was 3 hours.
Sir, distance is 20 kilometers and displacement is 1 kilometer.
Yes. So in this case, what is his speed? Speed, will it not be 60 kilometer?
20
That's
kilometers.
his speed. That's the total distance. And the time that he took is 3. So this speed, I'll write the formula again if you're getting confused. This is distance by time. So is that not equal to 60 divided by what was the time that he took? 3 hours.
20
So
kilometers.
this is his 20 kilometers per hour is what, folks? 20 kilometer per hour is what? It's the speed. Now coming to displacement, it's still 3 kilometers. So from this, you can calculate velocity. Velocity is given by displacement by time. So in this case, the displacement is only 3 kilometers and the time that he took is 3 hours. So it's 1 kilometer per hour. Are you absolutely clear between the difference between speed and velocity? It may be the same. In case of A, speed and velocity are the same. Why? Because distance and displacement are the same. In the case of B, speed and velocity are different. Why? Because distance and displacement are also different. Clear, 100% clear, all of you. If you are good with this, we'll solve some numericals.
Okay, sir.
Anyone having any doubts, please ask me. Yes, are you good, everyone? Is everyone good with the concept of motion, distance, speed? Sorry, motion, distance, speed, displacement, speed and velocity by now. We'll come to acceleration a little later. But are you good with these 4, 5 things, all of you? Absolutely crystal clear.
Yes, sir.
Yes, sir.
Wonderful. Chalo, next is the next thing that we are going to do is some numericals. Now open your other sheet, which has some questions. Otherwise, we'll do a lot of theory and do no numericals. We don't want that scenario. We will solve some questions. We'll not be able to solve all the questions with what all we have learned so far, but we will be able to solve some. Let us try those. Let's solve question number 1, folks. It's an easy one. It's an easy question. Let us try number 1. What does it say? Aryan started from home and traveled 40 kilometers towards east. So I'm sure class 9 folks, you are very comfortable with the directions. So if Aryan started from home and traveled 40 kilometers east, and if I take this as his home, then you will all agree that Aryan traveled 40 kilometers east. If this is point A and this is point B, then this is the direction that we are talking about. This is east direction. I hope you are clear. Then what does this guy do? What will be the magnitude? And then, and then he moves north, 20 kilometers north. So this is north, folks. Are we clear about what the question is? And if this depiction is in alignment with the question, this is 20 kilometers. All right. So now we are to calculate the distance and displacement. Hey, it's a very easy question, is it not? What is the distance? Now you can write the steps. Let A be let A represent Aryan's home. AB is equal to 40 kilometer and BC is equal to 20 kilometer. Hey folks, this is east and this is north. So don't you think that this is perpendicular? East and north are perpendicular, 90 degree, right? Therefore, the total distance will be how much? Can somebody tell me the total distance?
60 kilometers.
60 kilometers.
60 kilometers.
It is just what he has actually traveled, right? As simple as that, actually traveled. So the total distance is AB plus BC, and that is equal to 40 plus 20 kilometers. Don't miss out on the units. This is 60 kilometers. Done. First question done. What is the displacement? Get to the definition of displacement. It's the shortest distance between the initial and the final position. So you can see that this is definitely not the shortest path. He must have gone to meet some of his friends or whatever after the exam. God knows. But the shortest distance, you all agree that the shortest distance is this. I am writing this, and there is no convention as such, but I'm drawing this in arrow to indicate that this is not the actual path that he took, but this is the shortest distance. Now, join AC. You know that AC is the shortest path, right? AC is the shortest path between A and C. So can we say that AC is equal to displacement, folks?
Yes, sir.
Hey, online folks, I'm not hearing you enough. Is this obvious? Is this making complete sense to all
Sir,
of us?
Yes, sir.
Everyone, I don't know.
Sir, Pythagoras theorem.
Apply Pythagoras theorem. So what have we learned Pythagoras theorem for? To apply, right? So in triangle ABC by Pythagoras theorem, what do we get, folks? AC square
AC square. AC square
AB
plus B.
square plus BC square. That gets us what? AC square is equal to 40 square plus 20 square. Be careful over here. So this comes to 1600 plus
Sir,
4.
root 2000.
AC square comes to, yes, so it will be 2000.
Sir, root 2000.
4 AC will be square root of 2000. Okay. So it is 100 into 20, 100 into 20. So I'll just tell you what the answer will come to. 100 into 20 is 2 root 5. If you resolve this, this is the answer that you will get. This will be 200 root 5 kilometer will be the answer. Copy this down and let me know if you have any doubts anywhere, folks. Don't just copy. The solution is all there on Google. We are attending this class so that we understand and ask doubts. So don't just copy just like a parrot does. Just make sure that you have understood. And if you have not understood, you know what to do. Ask me. Copy this quickly. We'll solve the next question. Are we good, folks? Are we good with the first one? Shall we move on to the second question?
Yes, sir.
Yes, sir.
Wonderful. So I hope you people are following, folks. I hope you people are understanding. And don't just keep quiet if you have not understood. On a Sunday morning, on a holiday, we are attending this class not just to not understand, folks. All right. I hope no one is kicking anyone out of the session now. All of you. Are we good, everyone?
Yes, sir.
Yes, all of you. I hope everything is stable now. No throwing people out, no muting, and everything is going on. Also, Shreyas and Sankalp, just oversee karo. If somebody is not on mute, please mute him or her. Sometimes by mistake somebody might have gone on
Yes, sir.
unmute. Yeah, so just वो काम कर दो मेरे लिए, okay? Thanks. चलो, question number 2. It is now, again, question is not just about solving, folks. It's not just about solving. It's about understanding the underlying concepts. Please get this right, all of you. This is a square. Even before I solve the question, I want you people to understand this in totality, all of you. You have understood the difference between distance and displacement. Now, just tell me, don't worry about the question. We'll come to that. If you have understood the concept, you will get the solution. It's about the process, right? You would have heard the Indian cricketers talk about process. We follow the process. If you follow the process, the output is bound to get right. Now, suppose somebody starts from A and he is walking along the perimeter. His PT1 exam just got over, and the next morning he has nothing to do, or he is like just wants to be on his own, and he's walking around in a rectangular park, A, B, C, D. So now, if this is 10 meters, folks, if this is 10 meters, he starts from A, he completes one cycle from A, B, B, C, C, D, and he gets back to A. Listen to my question properly. Once he reaches A, what is the distance that he has traveled?
Sir, 40 kilometers.
40 meters. 40 meters, because the distance is the actual path. But what is his displacement, folks?
Sir, 0.
What is his displacement?
Sir, 0.
Why? Because displacement is the
Sir,
shortest distance the initial and the final position. Hold on. Yes, I heard your answer. Let me explain now. 0 is the answer because it's the shortest distance between the initial and the final position, right? If you have started from a point and you have reached back the same point, you have not moved at all. Your initial position is the same as the final position. So the total displacement is what it being the shortest is the shortest distance between the initial and final position. There is no change in the position overall. So displacement is 0. Now, if he just walked AB and BC, if he just walked AB to BC, then what would be his what would be his distance, folks? AB, BC. You all agree that the distance will be 10 plus 10, 20 meters.
20 meters.
Absolutely no problem. But in this case, the displacement will be the diagonal of the square. Is that also clear to all of us? Because displacement is the shortest distance between the initial and the final position. In right triangle, the shortest distance between this and this is the diagonal of the square. In this case, if you take a right triangle, it will be the hypotenuse. Okay, so with this understanding, let us solve this question. A farmer moves along the boundary of a square field of side 10 meters in 40 seconds. What will be the magnitude of displacement of the farmer at the, okay, so what all is given? It is a 10-meter field. A, B, C, D is a square field of side 10 meters. Yes. Now, what does this farmer do? The farmer moves along the boundary of a side in 40 seconds. So, what moves along the boundary? So, for one cycle, just get this right, folks. For one cycle, distance moved is equal to 4 into 10 meters, and that is equal to 40 meters. Why have I done this? It's a perimeter of the square, right? We know the perimeter is 4 into side, distance moved. And how much time does it take to actually cover this distance? So the time taken is how much, folks? Time that he takes is 40 seconds. Therefore, can we calculate speed? Speed is what? Distance by time. So it comes to how much, all of you? 40 by 40. So is it not 1 meter, 1 second? Hey, what have I done? I have done something wrong. Hey, speed is distance by time. So it's, yes, it's 1 meter per second. Is everyone good with the speed, folks? 1 meter per second is the speed of the farmer. Speed of the farmer. Yes. Now, get this formula right. You have distance is equal to speed into time. Okay, so this is the formula that you should remember. And from this formula, you can derive everything. So speed will be what? Distance by time. Time will be what? Distance by speed, and so on. Now, what information do we have in this question? What will be the magnitude of displacement of the farmer at the end of 2 minutes 40 seconds? So at the end of 2 minutes 20 seconds, at the end of 2 minutes 20 seconds, where will he be, folks? So let us calculate this. This is equal to what? 2 into 60 plus 20, right? We want to convert everything into seconds so that we get it right. So this will be 120 plus 20. So this will be 140 seconds. So after 140 seconds, where will he be? In 140 seconds, the distance moved will be how much? Apply the formula that we have here. Distance moved is equal to speed into time. What was the speed, folks? We calculated it there. It's 1 and time is 140. So is the distance not equal to 140 meters? Are you all with me? In 140 seconds, this guy has moved 140 meters. Yes, all of you, 140 meters. So now, how many times has he completed the cycle? So this is made up of how many cycles? If you divide this by 40, you will get the number of cycles, right? So the total number of cycles is how much? Is equal to how many cycles did he complete? 140 divided by 40.
Sir, 3.5.
3 plus something, right? 3 number of cycles, and then there is some remainder. So number of cycles completed. Number of cycles completed is how much, all of you? Is 3. After he completed 3 cycles, that would have taken care of 120 meters. How much distance is he still left, folks?
20 meters.
Yes, so distance left after 3 cycles, is that not equal to 140 minus 120, and that is equal to 20 centimeters? So from here he started, he had taken 3 rounds, he reached here, and then he moved 20 meters more. Okay, so the question is, what is the displacement of the farmer from the initial position? So how do we calculate the displacement, folks? I now leave to you to tell me how to solve this question. Have you people understood, all of you? If we first calculated the speed and then we calculated the distance moved. So he has completed 3 cycles. When he completed 3 cycles and he started from here, he has reached the same place, point A. Yes, all of you. From point A, he still has 20 centimeters to move, which means he moved A, B, and B, C. His final position is C. You all agree that his final position is C if he started from A?
Yes,
If
sir.
A
Displacement
is
is
the
10.
initial position, no, displacement is not 10. How can it be 10? This is the
We
final.
have to do Pythagoras theorem.
This is the initial position. This is the final. You have to use Pythagoras theorem again. It will be the square root of 10 square plus 10 square. Square root of 200 will come to 10 root 2. 10 root 2 is the answer. But I want you people to solve this and see if you are getting that answer. Do this quickly, folks. I'll give you people 2 minutes. After that, I will erase what all I have on the board and then solve the Pythagoras theorem part. But I hope you people have got it. Just let me know if anyone is having any trouble solving this. Yes, folks, are we good? Have we understood what we are looking at, folks?
Yes, sir.
Yes. So overall, look, I'm just summarizing what all I have said. This guy can complete 1 cycle in 40 seconds. So from that, we can calculate his speed. And then we see that in 2 minutes, 20 seconds, he completes 140. 140 meters means what? 3 cycles means 120, 40, 80, 120. So he has reached 120 and he still has 20 centimeters left, which means he is walking this and this. So the initial position is A and the final position is C. The total displacement is how much? In triangle ABC, we know AC is equal to how much? AB square plus BC square, right? It will come to 100 plus 100, and that will come to 200, and this is equal to 10 root 2 meters. So This is displacement. Can somebody tell me the total distance covered by this guy? This question is not there in this question, but can somebody tell me the total distance? His displacement is 10 root 2. But what is the total distance that he has covered, folks?
140 meters.
Is this not what it is? 140 meters, right? He has actually walked 140 meters. This is how we summarize. He has actually walked 140 meters, but the distance between the shortest distance between his initial and final position was only 10 root 2 meters. Treadmill, for example, you complete 5 kilometers. Your distance moved is 5 kilometers. But what is the displacement on a treadmill? What is your displacement? Yes, all of you.
So zero.
Because you have not moved any distance. The shortest distance is still 0. The distance moved is 5 kilometers, but the displacement is 0. Yes. So we will actually do one concept now before we have only 15 minutes. This is a huge chapter. I have planned this across 3 sessions. So this is the first one. The distance time and the velocity time graphs. Let me turn the recording on. Oh, I've already turned it on. All right, we're good. Okay, so the distance time and the velocity time graph. What does this mean? There are 2 dimensions here. Distance and time, and we are looking to plot them on a graph. Get this right, folks. There is a huge confusion amongst class 9 students, I have sensed, in getting this right. Get this right now. We use the x-axis. You know that this is the x-axis. Yes, we use this axis for time, and we take the y-axis for distance. Okay, this is distance. We will measure this in meters per second for this graph, and here it is in seconds. I hope you know how to read graphs. Let me know if there is any confusion. So here I'll take the motion of a body spanning 5 seconds. 1, 2, 3, 4. 5 seconds. Any confusion, folks? I hope you are absolutely clear so far. And on this axis, I am representing the distance covered. And here I write this in multiples of 5, 5, 10, 15, 20, 25. Okay. And if I have a body in uniform motion. So do you know what uniform motion is, all of you?
Yes, sir.
Yes, sir.
When a body covers equal distance in equal intervals of time. If it is circular motion, the earth revolving around the sun or the moon revolving around the earth are perfect examples of uniform motions because they don't change their speeds. It's at the same speed. If you put your treadmill at 15 kilometer per hour, well, don't put so high, I think. Make it 5 kilometer per hour. If it is 5 kilometer per hour and if you are running on the treadmill, don't you think that you are traveling equal distance in equal intervals of time? The speed is not changing, folks. Is that clear, all of you? Let me hear from you if you are in complete alignment with these 2 examples. Uniform motion, right? So in this case, let us draw a graph. So this was 0 or O. In 1 second, at the end of, I'll just draw this table here, okay? At the end of, and this is the distance moved. At the end of 1 second, where was this body? Let's say he had covered 5 meters. 5 meters. At the end of 2 seconds, let's say he was here, 10 meters. He was 10 meters. At 3 seconds, 15 meters. At 4 seconds, 20 meters. If I actually join all of these points on the graph, (15) will correspond to this. I've not drawn the scale graph using proper scales, so I might get the points here and there, but this is 5. So you will get something like this. So in this graph, you have these points. At the end of 1 second, so are you able to see, folks, that this is a distance time graph where the velocity is constant? Very, very important. The velocity is constant here. Is that a fair thing to say that the velocity is constant? Why? Or let's call it speed. Here we are talking about distance, so let's call it speed. So in this case, what is the speed? Can you derive the speed at for each time? In 1 second, the body has covered 5 meters. So what is the speed? It's distance by time. So distance is 5 by 1. So it's 5 meters per second. In this interval, what is the total distance? 10 minus 5, right? Hey, after 2 seconds, it was 10 meters, and after 1 second it was 5. So in this time interval, has it not covered 5 meters in 1 second? In every interval, you'll see the same: 5 meters in 1 second, 5 meters in 1 second. So in all the cases, it is 5 meters per second, 5 meters per second, 5 meters per second. So for a body in uniform motion, for such a motion, the distance time graph is a straight line as shown in the above graph. If you have understood, copy it down. If you have not understood, even then copy it down. And once you have copied, ask me what you have not understood. Let me know, folks, once you have copied and you have understood.
Done, sir. Understood.
If you have not understood, ask me. I will explain. Done and understood. All right. Anybody who is done but not understood? Now, just quickly, folks, we have 6 minutes left. We want to make the most out of the remaining time. So let me know if we don't want to end this class with even a single person having not understood even one single thing. We want everybody in this class to have understood and be aligned with everything that we have tried to learn today. Otherwise, it's just useless. So let me know, folks, if you are in alignment. No one says anything, so I presume that everybody is good. All right. Now, let me just change this thing. If I have distance moved, in this case, I will just make some changes to the distance moved. If the distance moved was 5 meters, like the first case, after 2 seconds as well, the distance moved is 5 meters. After 3 seconds, be 5 meters per year. at the end of 4 seconds, it has, don't think that this is 5 plus 5 plus 5 plus 5. It actually means at the end of 1 second where it was. It was 5 meters from the origin. At the end of 2 seconds, where was it? It was 5 meters from the origin. At the end of 3 seconds, it was still there. At the end of 4 seconds, it's still there. So in this case, how will my graph look, folks? If I start
The
plotting
parallel. So the
5,
graph looks parallel.
3, 5, 4, 5, the parallel to the x-axis, right? The graph will look something. The graph will look something like this. I have not drawn the dots properly, so let me just manipulate this here. But these are the 5 points that I want to represent on the graph. Absolutely clear, folks. So in this case, what is this body doing, folks?
The body is at rest.
Is the body moving? Not moving. The body is not moving. So when a body covers equal distance in equal intervals of time, that was uniform motion. This is another graph where the body is not moving. The body is at rest. The body is at rest here. The body is at rest. And in distance time graph, this scenario is represented by a straight line parallel to the time axis. Time axis in this case is our x-axis. So I think we will stop here because we don't have more time now. I want to very quickly hear you all as to what part of it was a discovery for you, or if something was still not clear to you. I will need your inputs, folks, to be able to fill all the gaps that you might have experienced in this session. So for now, very quickly copy this. You will see that the speed in all of these cases, will be, there is no movement. So the distance moved is 0, 0. So in all the time, the distance, the speed will be 0. If speed is 0, it means the body is at rest. This is what it shows. Okay, so we have looked at 2 distance time graphs today. One which was inclined to the x-axis, time axis, which showed that the body is moving with a constant velocity, no velocity change, but the body is moving. And in the second time, when this is parallel to the time axis, it means that the body is not moving. We will look at more graphs in the next session. We'll also look at velocity time graphs. We'll derive the equations of motion. We'll look at the 3 equations of motion, and we'll try to do more numericals in the next class. That's all, folks. Have a wonderful Sunday, and we'll catch up next sometime whenever we have this session again. Thanks all for joining.
Thank you, sir.
Thank you, sir.
Bye.
Thank you.
Thank you, sir. Bye, sir.
Thank you, sir.
Thank you, sir.
Thanks all. Thank you.